So the William W. Hay Railroad Seminar Series here is sponsored by the National University Rail Center here at the University of Illinois at Urbana-Champaign. And on behalf of all of us, we thank the USDOT for their support. It is greatly appreciated by those of us here on campus, as well as those participating via the internet. I would also like to extend a welcome to those of you joining us via the internet, which includes representatives from another long list. STV, Ganesh, Anaconda Rail Holdings, BNSF Railway, Train Dynamics, Hanson Professional Services, HDR Engineering, AECOM, Parson, Mont McDonald, Sistra, Quandel, ESI, Genesee and Wyoming, Amtrak, Patrick Engineering, LTK, Metra, STV, Kansas City, and Kansas City Southern. We're really glad you could join us this afternoon. And if any of you dialing in or here in person would like to receive PDHs for your participation in the seminar, please send LB an email with your information as described in the email announcement for this seminar. So the railroad industry, just about everybody else, is in the midst of a revolution due to the massive implementation of numerous digital technologies. Railroads are awash in massive quantities of new data, and that trend will do nothing but expand. Powerful new analytical tools are needed to enable railroads to take full advantage of all that this digital revolution has to offer. GE Transportation is a leader in development of solutions to achieve a variety of objectives, some of which have challenged railroads for more than a century, and all of them critical to the future success of rail transport. Our speakers today are Jeremiah Dirnberger and David Lennon with GE Transportation. Jeremiah is the Principal Technical Product Manager for Yard Products at GE. And prior to joining GE, he worked for 2 North American Class I railroads supporting field operations, performing simulation, data analysis, and capacity planning. He completed his BS in Industrial Engineering at Montana State before coming here to the University of Illinois, where he completed his thesis on improving hump yard operations. His work has been published in the Transportation Research Record and in several conference proceedings. He's a member of 2 ARIMA committees and the Informs Railway Applications section, and is a regular presenter and panelist at industry conferences. David Lennon is a senior software engineer based in Chicago, Illinois, also with GE Transportation. He earned his BS in software engineering from the University of Florida, and he's currently working on a hump yard optimization model for GE, where he's worked since 2012. Please join me in welcoming David and Jeremiah, who'll talk about leading the digital transformation of the rail industry.
On a yard planning tool and system that we're working to implement right now with Norfolk Southern. So we'll dive in. I'll let you know right off the bat. A couple of slides here are missing some of this graphics in the background. So the PDF online should have everything, but we will do our best to work with that. So GE Transportation, yes, we are currently a part of GE. That is going to change at some point here in the next year. We are being divested. But we do a lot of things to move the world. So probably best known for locomotives. Our locomotives are really renowned as the industry best. Our diesel electric locomotives for freight. That's where our focus has been for many years, well over 100 years. We do a lot of work in the mining space, so equipment for various mining operations all around the world. We also build engines for marine, whether it's military or commercial vessels. We have a manufacturing component. A lot of that's making the components that go into a lot of our engines and equipment. The digital solutions down there on the bottom is actually where we work in, so we're going to talk and focus mostly on that today. As well as we have some work being done offshore drilling platforms, again mostly around the engines and equipment to do the drilling, stationary power, And then we do a lot with our services, which has to do with servicing locomotives, tracking their performance, keeping those assets running at peak efficiency. And so that's kind of the breadth of what GE Transportation does. And again, we're currently part of the bigger GE, which has several business units inside of it. So right now, as many of you in this room are really well aware, the rail transportation industry is facing some pretty in-depth and unprecedented challenges, which really are opportunities if we look at it in terms of where the industry can go. We see a lot in the carload business, right? Carloads, they grew last year, but they're still well below levels that probably since 1988. Of course, that's a lot, of that's from the decline in coal, which has affected and really caused a lot of the companies that we work with, the Class 1s, to shift their focus and really look at intermodal and other opportunities for growth, which has its own, different sets of service design needs in order to deliver what the customer expects. And so the railroads have been navigating that. There's also, of course, a lot of financial pressures from Wall Street. And so we've seen, the effects of that, and we're still, in a lot of cases, kind of moving through those transitions. And at the same time, the rest of the world has been advancing on the digital and on the technological side. And so there's become, this sort of expectation in terms of what the railroads, could be doing based on how we look at the rest of the world in terms of transportation and logistics. And this slide just kind of starts to highlight some of that. A lot of the talk was around trucking, improvements there, whether it's, well, maybe not quite, say, fully autonomous, but the pathway to do that, whether you're moving to platooning, whether you're doing sort of autopilot, self-assist type operations, a lot of that's already been in place. I know J.B. Hunt actually has essentially all of their trucks equipped. They'll keep it in the lane. It won't hit something in front of it. So you're starting to get to that point where you're having to have more efficiency and safety for the trucking industry. And so what does that mean if that trend continues, which we expect that it will, where you start having, say, a single truck in leading, and then behind it you've got maybe 3 or 4 trucks that are connected to that first truck that don't have drivers in them, but the first truck does, and you start to have those platoons. Does that start to eat into rail market share? And does that shift that point of where the intermodal business that currently is growing for railroads and shifts that to a place where the trucking can really start to eat away at that? So you got a lot going on in that space, and how should the industry respond to that? Of course, coal, while it's never going to probably go away, it's still, it's declining, and so the railroads can't expect to have that nice cushion of revenue for moving the very heavy bulk commodity around the country, and around the world. Supply chains, all of us probably have used Amazon Prime, and we expect that, hey, I order something, I should have it in 2 days or less, and I know exactly where it is in that journey. And so we've got, we've had quotes from customers of the railroads, and they're like, rail ETAs are meaningless. Why is it that when I order something from Amazon and say, my dog toys, I know exactly where my dog toys are, and the railroads can't tell me where the car is? In today's, in 2018, we should be able to manage that more effectively. And so that's the kind of pressure that's starting to be exerted from rail customers, because their expectation is this Amazon world that we live in now. And then with that, we also have the aging workforce. We've seen a lot of retirements in the last few years. That's going to keep going, but they're not being replaced one for one. And so you're asking all of the major railroad carriers, the people that are still there are doing a lot more than that position did even just a few years ago. And so that knowledge, goes with it. And so what was done very manually, very, sort of institutionalized, has to get transferred somehow. And so we have to be able to, to adapt, and adapt quicker than the industry has done in the last, several years. And the landscape that we face, this is what, when we talk transportation, I know we focus in on rail stuff. That's a lot of what GE Transportation does. Of course, everybody in this room, that's a lot of what you're working on. But if we think about it in the bigger transportation landscape, which is really what railroads have to start thinking like, okay, we're not just a railroad, we're a transportation, solution provider. In the world that we live in today and that we operate, We have disconnected systems and processes. So we've been working on some solutions that just even going from short lines to Class 1 railroads, they still don't like to share information between those two, and the car is moving between those those carriers, and they're still not necessarily willing to necessarily share the information to make that more seamless. And that's true whether you've got 500 plus short lines in North America, you've got several Class 1s, you've got the ports and the terminals, or they're separately owned and operated. They're doing their things. You've got your shippers, and they've got their own systems. There's multiple systems in that market space, and so things aren't really integrated, and it makes it very hard to have that same kind of seamless customer experience that we've all come to expect now. When it's not, that's a lot of the reason why Amazon's doing what it's doing and getting trucks and getting its airplanes to start moving stuff around. In fact, starting even to move into spaces that traditionally you wouldn't think that they would want to. But they want to control the supply chain. And so that's because they got to take those efficiencies out. So this introduces a lot of inefficiency. And on top of that, we get the challenge of dealing with a lot of legacy architecture and and technology. Most of what happens on the railroad as far as car movement today still happens in a mainframe or a DB2 type world. This is 20, 30, 40 years old, and the rest of the world's gone, done its best to get beyond that. But that's what's actually managing the movements of trains and cars across most of the North American network. And so we've done a lot to work around that. But the question is, how are we going to continue to advance? Because that system there, when you talk to a port or a terminal, they may have actually be much more advanced in terms of their architecture and how they're actually managing their information. So how do you get those two different worlds to talk? And so this ends up, the business effects are over here on this side of the chart. So we have low asset utilization. If you really think about the turn times for some of the rail cars in North America, and even train speeds and things, the next slide we'll talk a little bit more about that with actual numbers. But we get high operating costs, low network velocity, and low visibility and delivery reliability. Again, the world is coming to expect that we should know very clearly where things are, where is my inventory, where is it moving, when is it going to get to me, and can I trust that when you said it's going to get to me, it's actually going to get here. And so the effects of that not just affect North America, which I think we're probably most familiar with, but I know several of you aren't from North America, so we've got some examples, of course, outside and how it affects the global economy and really the global transportation industry. So North America, we got a lot of unexpected train delays. 20 plus hours terminal dwell. That number I think has crept up in the last. I know it's crept up in the last few weeks. So we're probably some places well over 30 again. Train speeds. And when we talk to people and you say an average train is 20 miles an hour, and we think that's actually pretty good, and they're like 20 miles an hour. So there's of course a lot of fuel costs, about $10 billion of annual fuel costs that are encompassed in those things. India. We're doing a lot in India right now. Their operating ratio is 91%. Now, 20 years ago, that would have been I guess we would have thought that's actually not. I don't say it's good, but that was kind of normal operating ratios for a lot of Class 1 railroads in North America. Now we're down in the 60s and the low 70s, and probably pushing into the 50s in a lot of cases. And so, what can India do? And they need to do that, and that's why they're investing very heavily in their railroad infrastructure. Very high accident rates in both India and Brazil, and then of course what that has to do and the impacts to the network. I actually got to go to Brazil last year and see their operations. Really good railroaders, but they deal with a lot of things that we don't necessarily see here in terms of how they interact with the larger world down there. Sub-Saharan Africa, very high dwell times. Again, probably even they are at lower train speeds than we even experience here. And so this all has an impact on fuel. And so we're trying to look at all these things and make that shift in the right direction. That's Chris.
Does the Indian operating ratio include all of their passenger operations?
I'll see if I can find that out. I don't know off the top of my head. Yep.
Effect, obviously.
Yeah.
compared to a North American freight railroad?
Yeah, I'll look into these slides. I didn't put the actual numbers together. I'm thinking we would have actually tried to filter that out and look at just freight because that's really the space that we operate in. But I can check with our marketing folks and find out for sure. All right, so now we're going to, sort of that's the space, that's the world that we're operating in, and we want to, of course, impact that and make a very positive shift, for the rail industry. And so digital solutions, again, where Dave and I work in, we're really driving that transformation. And so there's several components of that transformation that we are approaching at and looking at from GE's perspective, GE Transportation. And so the first there, and I don't necessarily say this is like, they go in sequence. It's just sort of how I would say that probably the asset side of things, that's where the most work has been done over the years, because we make locomotives. And locomotives have lots of sensors. They're very expensive assets. They want to make sure that we're turning them and using them as effectively as possible. So that being the first pillar, and that's where a lot of the investment has been done over the years. So we're starting to look more at the car side of things. The challenge is that, rail cars, there's a lot of them. How do you sensor them up? Is it worth the investment? Who maintains them? There's a lot of questions that still have to be figured out about that. And so if you can really optimize the asset performance, the individual pieces, the next thing that we are actually making a lot of really good progress on in the last few years is on the train side of it. So train performance. How do you take that entire train and really you're managing it from both a fuel perspective, from an operating perspective, from being as it goes over the network. So looking at the whole train, and then the third pillar, which is network, and that's where Dave and I work in, is really looking at the systems, the line of road, meet pass planning, yard and terminal planning, operation optimization, and really looking at what we can do to move things through the network as fast as possible. Because we can make the best locomotives in the world, which we feel that we do, but if you can't move them through the network because the network is congested, are you really doing everything that you can? And so we've got a lot of exposure in this space. And then ultimately, the overall transportation management, which is really the end-to-end solution. So we're saying from the mine, right, pit to port. So the entire spectrum, whether I'm moving in a rail car or a truck or whatever it takes. And I think a good example of this is CN. They don't really think of themselves as a railroad anymore. And they're probably they are the most advanced as far as this curve goes. They think of themselves as a transportation provider, a supply chain solutions provider. And so they actually have a trucking company that they bought. And the way CN thinks of it is they said, okay, you're a lumber company, right? Let's just say Lowe's or Home Depot. And I'm going to make sure that you have 2x4s and you never run out of 2x4s. But you give me control of your supply chain. And so by doing that, they have that trucking company. They prefer rail because obviously that's the lowest cost solution. But if they end up running into some kind of congestion where those 2x4s aren't going to get there, they use the trucking company to make sure that they get the inventory that's needed to that location. And so they're not looking at it in the same way, and they've done a lot of investment to move the technology footprint in that direction. And so the question is, okay, what's the rest of the industry going to do about that? Should we as a whole really be thinking of it, okay, all we can do is move stuff by rail, or how do we make sure that we ultimately deliver the solution, which is they don't run out of stuff? And so, and that's where these components start to really fit in, so that you can, not only worry about the stuff on the left is kind of more cost. Let's pull the cost lever, keep our costs down. But when you really start to get onto the right here, that's really about improving the service reliability, improving the customer experience, and being able to manage that entire shipment from end to end as it goes from whatever it is, port, customer loading, delivery, all of those pieces there. And again, we're working to look through this entire chain and take this landscape and revolutionize it so that it can be the most effective. And again, I apologize. There's a really cool graphic behind this that has that kind of those pieces there. But the pieces right now, again, at GE Transportation, we actually have a lot of the pieces in place. We're not the only ones that do this stuff, but in a lot of cases, we are leading the industry and have some of the best solutions in these areas. And so We're also the best positioned because of that expanse of where we operate, where we can really look at each one of these 4 pillars and integrate across those, and that's the vision and where we're going. And so right now we've got 17,000 locomotives that we monitor on a regular basis. That's worldwide. So not only we build the locomotives, they're sensored up, they're out there operating, but we actually have control centers. I know there's at least, I think, 3 in North America that actually are sitting there monitoring those locomotives real time and helping to make sure that they are being used as efficiently as possible. Local control, that's has a lot to do with our distributed power and train performance system. And so 20,000 of those systems are installed. So as you can see, not just on GE locomotives that we monitor, but there's also other locomotives that we have installed that on as well. And then kind of the offshoot of that is also our remote control locomotive product, which we now have the ability to not just remotely control yard locomotives, but also road locomotives. And so if you have that Locotrol, our latest version of that, you can actually remotely control a Dash 9 or the latest Tier 4 locomotive, just like you would a GP38 in the yard. So really cool where this is taking us to. And part of that is that next bullet down there, which is the GoLink, the edge device. That's really the thing that we plug into the locomotive that takes all that data. And now we're actually using it and doing a lot of the data analysis right there on the locomotive instead of sending it all to the cloud and then having to go back. A lot of it's being done right there on the edge, right there at the device, so we only pull out what we need, which of course improves your performance. So there's about 10,000 of those devices out there in the operating today. 10,000 Trip Optimizer, that's our fuel cruise control for locomotives, saves tons and tons or gallons and gallons and gallons of fuel. Those are installed. 500 short lines, so essentially just about, I think it's 95%. 95% of the short line railroads in North America use our transportation management system to manage their car and train movements from an inventory perspective on their network. And so that actually gives us a lot of opportunity to really try to move and synchronize things across those networks. And then we have about 70 intermodal terminals using various intermodal planning tools, whether it's Oasis or our latest one, which we call Smart Intermodal. About 20 million lifts a year are controlled by or planned by GE systems. So really a lot of stuff across that full spectrum. And so these are some of the products and then those various buckets that we're talking about. First one being asset performance management. Locomotives, again, being where we've got the most experience and done a lot of really great stuff there. Moving into the rail car, and then now on the track and wayside analysis. So taking advantage of a lot of stuff you guys have probably looked at with drones and camera analytics, actually having a locovision on the front of the locomotive to do and analyze track as the train's going over it. That's one tier of that. Over there, train performance optimization, like I mentioned, Locotrol, the remote control operations, and then Trip Optimizer, that all falls under that bucket. Network optimization, that's where we're going to talk about in more detail today. So we have our precision dispatch system, which is used at Norfolk Southern. CN is currently installing in the US, transitioning to our system. BNSF as well has it, I believe. Movement Planner, I've got an example of that on the next slide, some specifics, but Movement Planner, that's our line of road meet pass planning tool. NS, BNSF, and then Horizon, and then there's actually ARTC in Australia, so 2 in Australia, and then 2 here in North America. Our yard planner system, Dave's going to talk about that in more detail. And then we also have smart intermodal and automotive ramp management, which are moving into that sphere of planning and optimization for those operations. And then up at the top part there, transportation management. Rail TMS, that's the short line product that I was talking about. And then we also have a shipper TMS, which is used by a lot of the bulk carriers for managing their frac sand movements across the various channels of distribution, oil, forest products, just not just rail there, but rail's a big part of that. Yes?
Just out of curiosity,
Sure.
trip optimizer or the yard road RCL, is that compatible with EMD locomotives or other manufacturers' locomotives?
Yes. Yeah, actually, a lot of the RCL is actually installed on the EMD locomotives because that tends to be what's in a lot of the yards. And then, yes, we've actually, so a lot of our components can be installed on, both manufacturers or either other manufacturers of locomotives as well. In fact, in this slide, in that top left corner, one of our asset performance management examples that we just did in the last year was in Germany on Deutsche Bahn, and they're all EMD locomotives. And so we actually installed our APM software using Predix to analyze and prevent prevent the failures and analyze it and do the predictive maintenance. So we reduced about 25% reduction. So we're not limited to just GE stuff, but obviously that's where we've got the if we can do it while we're building it, then that gives us a lot more data that we can use as well.
So in terms of like positive train control, like the asset manager of your locomotive, is GE doing anything like developing software for that, or like is there like some third-party software being installed on the software and hardware being installed on your guys' locomotive?
Yeah, the question was, remember to repeat the question. Positive train control, are we operating or really installing and working in that space? We obviously, it affects us, and so we've got, it's probably more on the dispatch side and some of those areas and how we integrate there. So it's not really something that we have like a focus area or not doing a lot of the integration or the back office stuff. Like that's not something that we're really involved in. Obviously, there's as those components get installed, and they would we work in that. So it's not. We definitely have exposure to it, but it's not a core competency of what we're working on. So okay. All right. So yeah, these are just some examples of what we've done in the digital solution space. Like I mentioned, the DB cargo one there, 25% reduction in failures, train performance. That's, again, a lot around chip optimizer, BNSF and CSX, about a 10% improvement in fuel efficiency, and what that translates to is about 900,000 gallons of fuel saved each week. Network optimization, I was mentioning that on the previous slide. 2 Class 1s or 1 Class 1, and we're installing on a 2nd Class 1 right now. 1 international installation of movement planner. That's improved their velocity on their line of road movements by about 10 to 15%. And then this is really kind of one of the most recent, quickest, and I think one of the most exciting opportunities that we see right now is working with the ports. And so we just had a pilot that we did last year that's now expanding with the Port of LA. And it really didn't even involve optimization or anything from that standpoint. It was just connecting the data. So that if I'm, a ship that's coming in, that the information of what's on that ship and where it needs to go is being passed to the port and then passed to the various, whether trucking companies or railroads in terms of containers and where they're going. Like that wasn't even known. Like so the planning as far as downstream as what needed to be there and when was not really visible. And so we worked with them, connected the data, provided a portal, and that's the first step to start to open up this opportunity. And it went very, very well, got a lot of awards, and so now Long Beach, and I think we're pretty close to another port getting started on that as well. And that's the first step toward that sort of optimization path. All right, so we're going to dig into network optimization. So kind of focus in, and then, of course, the area that Dave and I work in is yard planner and yard products. But I want to give you the context of the bigger solution that GE Transportation is working on regarding what we're calling the yard of the future. And so yard planner is a part of that. It's a key component of it. And so we've worked very closely over the last 6 to 8 months, really. We started talking about this internally about a year ago, and then we had one of our great customers approach us, and we started working with them to lay out what's it going to take to digitally transform that railroad. And so this is a part of that. And so I've spent a lot of time in yard towers and buildings and stuff, and I'm sure some of you have as well. You go in, you look at it, and you kind of feel like you've gone back about 20 years in a lot of cases. Very, very manual in terms of the planning. Lots of things are still done on paper. There's selected automation. You sort of sit down at your desk. You got to come in, if you have an 8-hour shift, you got to come in a half hour early, but you don't get paid for that half hour. So you got to come in so you can talk to the guy before and find out some of what hopefully you need to be concerned about as far as what trains are where and what's going on. And so you do that handoff. Sometimes it's effective, sometimes it's not. Then you sit down, you probably spend a little bit, maybe an hour trying to kind of get your bearings about where things are. You're talking to your crews. You got to make sure that they're operating safely. You got the radio that you're using to ensure that things are being done. So you got a lot going on. And it's a pretty stressful, world that these guys and gals get to operate in. So, and you just, again, you kind of look at it, you're like, man, there's so much more that we can do with this. And so that's really where we started. We said, all right, what can we take to make, this world that this picture shows and move it into, really to the day and advance it into the future. A big area that's lacking, and again, where a lot of we're working on, is decision support. That's the planning algorithms that we have in Yard Planner, and so expanding that not just hump yards, but into flat yards as well. Planning is done, execution done very locally. So I'm trying to survive, right, just to get through today, and I'm not too worried about what happens to the rest of my network, or what's going to even go on tomorrow or the next day. I just got to get through my 8-hour shift. So moving away from that, real-time asset tracking. Yards, hump yards are a little better because you do have some automation, but if you go to the yard over here in the Champaign, CN yard, they can tell you what track the cars are in because they've got an inventory system, assuming that the person that's managing that put the cars in the right track. But as far as where on that track, unless I go out there and actually look at it, I can't say that these 3 cars are located at this point on the track, and there's a 50-foot gap, and then I've got another 10 cars. Like, you don't know that, and there's nothing telling them exactly where these assets are. Locomotives, of course, it's a little better. We've got GPS on some yard locomotives, but cars essentially are not, other than the AI tags, which again you have to have a scanner to see the car go by and then know where it's at. So how do we go from this to the future? And so the objectives that we did, and we worked through a design thinking process. We've got a really great design thinking group, user experience team at GE Transportation. It's really cool because they don't necessarily think of it, in sort of the railroad box that we think about stuff. They're looking at it from the sort of bigger tech box and what's out there in the world. So they helped us to kind of, okay, let's think about it. Let's not be stuck to the fact that we've got this and we've got that. Like, let's really just take those off and let's see where we can go with this. And so we worked through that, several sessions, in person, getting and just really thinking about what's possible. And so we came up with several objectives for the Railyard of the future, and this is where we're advancing. And actually, it goes across those pillars I was showing before, and really how we have sort of grouped ourselves from kind of a profit and loss perspective. Like this, crosses those boundaries, and we have to think of it as not just engineering or mechanical or transportation. I mean, we have to look at it as a whole system. And so the first objectives we've got is we want to have predictive maintenance, proactive decision making, and really giving informed recommendations to those that are making the decisions. So that's a lot of the space that we're working in right now, and really trying to bring, the way I describe it is like yard planner is like GPS for a yard. You still have to have somebody drive the car, but a GPS tells you where the best way to get there. So that's where we're working in right now, is getting that those GPS systems, GPS-like systems, installed in the yards, in the bigger network areas. And then if we move down that path, and then we start to get more into the world of automation, there's so much that's right now that we could call and put into place. So I call the yard of right now that could be right now. RCL, power control switches, the various systems that are in place, that you could really unlock a lot of productivity that doesn't exist today. But there's not a really holistic example of everything being put in place at one yard, with the planning tools like Yard Planner that would actually connect everything together. Like that just doesn't exist today. We're trying to make that happen, and I think you're going to see that here in the next, in the near term. But sometimes the focus usually is on one side or the other. Either they're really trying to automate, so we're going to put RCL in, and we're going to have single-man crews, and we're going to just do all that. But then there's nothing from a planning perspective to complement that. And so we could put the two together, where you're able to not only know where your assets are, what they're doing, where they are in the business process. You've got a really good planning tool like the one that Dave and the team have developed over the years that can take that information and provide the best sequence of activities to do all of that. And then potentially we've got some robotics out there. Our GE developed you can see the picture of the Grizzly there. It's a robot that can go into the yard. We had a class 1 that helped fund it initially. That class 1 changed its priorities, so now we're wanting to do more with it. But it can identify the air bleed rods on a rail car. It can go down and actually articulate and pull those bleed rods, whereas today a person has to do that. And there's a lot more that can be done there as well. So that's coming. I'm not saying that a yard's going to be set necessarily fully, without people, but eventually you could get pretty close. Optimizing asset utilization is really going to be a big driving thing of that. How do we get as much out of our tracks, out of our people, and as much as out of our engines and cars, by using technology to help leverage that. And then as you start to move down that space, we're going to open up new opportunities that we don't even realize exist today. Like we can't see that far in the future. So as we move down that path, we're going to see new things open up. We're talking a little bit in the car. Professor Barkin and I were about dispatching, getting centralized at some of the railroads. So a lot of where we see the future of how the operations are being done, it's not like today's world where, okay, I've got dispatcher, I've got the various sort of very segmented crafts. You really have a sort of a multidisciplinary team that's looking at a part of the network, and they're supported by planning tools that are giving them recommendations as far as what should happen and when these things should occur. And then they're looking at it and thinking, okay, is that a good decision? Yep, I like that. Let's just go ahead and follow that, or let's make some adjustments there. And you kind of the great way to describe it is, in fact, one of the guys in our design thinking group used to work for the NSA, and so he explains kind of the big command type centers and how they do that. Some of the stuff you see on TV is actually fairly accurate. And so you've got all this information coming in. We're not having to do every single planning decision because a lot of it's been automated, but they're able to really very quickly see something happens on the network, let's respond and go ahead and divert traffic, whereas in today's world, it just keeps going. So like what's happened down south here, we've got a derailment. Well, the trains are just backing up behind it and they're just going to keep doing that because there's no way to really feed that into there's not a feedback loop to say, let's do something different. And so that's ultimately going to drive that improved customer experience. And so that's where we want to take and move the industry towards. And so this is a high-level roadmap. We have a much more detailed version that we're working with our customer on. But this gives you kind of the path towards that specific to the rail yard and where we think it can go. And so that first column or sort of area there on your left, consistent data and control. That's really the yard that could be today. And so we're working right now, and hopefully we get rolling here on it to actually pilot this concept, and not just at a single yard, but on a corridor perspective, because that's really where you start to get the benefits. Is that I've got multiple yards, multiple systems working together. I'm looking at not just a single yard, but I've got multiple ones planning and doing things together. And so that starts to move towards that short term, which is really proactive network planning. So we're kind of going from visibility into really adding the planning tools and the things that are going to make it smart. And then longer term, autonomous, semi-autonomous yards. That's you think about Amazon and their warehouses. You have people do what people are good at, and you have really machines do the rest. And so making sure that we leverage that and do it in the right way that's going to make sense for the business. But the technology is either exists or it's going to exist very shortly where that can be done. And then longer term, we called it decentralizing yard activities. But I think what's driving a lot of this is in today's world, and that's just, if you expand it beyond just yards, but really toward sort of changing how we do trains. The reason we run long trains today is because I have 2 people on the crew, and then I have multiple locomotives. So if in the future I only have a single person and 1 locomotive, I've shifted the cost curve, and now I can actually run shorter, more frequent trains, which helps. Instead of running a 100-car train, I can run 2 50-car trains or 4 25-car trains, right? And now what does that do from the customer experience? That actually helps a lot, right? Because now I don't have to wait as long to leave to go on to my next connection. But then if I have a lot of smaller trains moving around the network, and the network can handle it because I've got like precision dispatch, I've got movement planner, I've got other tools in place that allow that management to happen, the reason for having giant yards now may not be there anymore. And so we don't know exactly what that might look like, but we want to position ourselves so that when we get nearer to that point, that we're going to be able to, again, maximize and use those assets as efficiently as possible. And a lot of the inspections, a lot of that stuff that we do now physically in the yard, could be done online, in the line of road. In fact, Riley, back when we were in grad school together, you were looking at the machine vision for the rail car inspection. That's here. So if that's being done, I don't need to have as much of my yard being tied up for doing that. So either I don't need as big of a yard, or I can move those activities elsewhere. And so this is probably the more vague and kind of abstract part, but the first 3 ones are pretty clear, and we have a path that we're working towards getting there. And then across the bottom here, we've got some of the supporting inputs. Definitely, there are things that we have to consider. Not the knowledge base of the railroaders that have been doing this for a long time. We have to make sure we don't lose that, or we don't ignore that. Of course, there's a lot of regulatory stuff we have to consider. Thankfully, we've been told, we'll worry about that. You guys just worry about the technology. And so, and then just as we start to really think about that sort of example I gave earlier about CN not just being a railroad anymore, that's where a lot of this goes into, is that railroads is probably not the way to think about it, because we have to be transportation providers. And so this kind of gives you the bigger context of where we're going with this vision. And now I'm going to have Dave. He's going to talk specifically about one of the foundational components of the rail yard of the future, which is our yard planner system. So, and specifically, we've designed it right now for hump yards. So, Dave? I'll just let you.
All right. So we've talked a lot about all the other products we have. This is a specific one, like Jeremiah said, called Yard Planner. So what is that? So there are 4 primary operations in a hump yard. So there's train arrival, so you got to handle the trains coming at you. The next one is humping, so you have to break those trains up. Next one, you go to pulling, and that's building new trains. And the last one being departing the new trains that you've just built. So that's quickly what it is. I'm going to go through each of these in a little more detail, and how we optimize or try to optimize each one of these. Overall, what we're looking at is trying to depart trains. So that is the most important input to us. We need to know what trains are leaving, when they're leaving, and what they need to take, and in what order. So we start with arriving trains. So we are fed information about what trains are coming towards us and close to what they're carrying most of the time. So we need to handle those, pick where we're going to have those trains park, and there's some logic around that to kind of make it easier for the people down in the yard to operate easier. So we'll park 2 trains next to each other so they can go through and do inspections or air bleeding all at the same time for 2 trains, so they don't have to walk down the track twice. And taking into account availability and other stuff that we know that's coming. And then after the trains are arrived and inspected, we move on to the hump part, which is probably the most important aspect to get right. So we go through and we know what's currently in the yard, what we know is coming, and we'll go through and evaluate based on what we need to get out, what kind of which receiving track we should hump next. So I just got a train in of 100 cars, and most of them are going on trains in the next 6 hours. That seems important. I should probably do that one. So that's the first part of humping. So that's the hump sequence. And just to clarify, if anyone doesn't know what the humping is, essentially in these yards, the trains come in, they park, and then when they hump them, they hook a locomotive up shove it down towards a hill and pull the pin on each car and just let it free fall into a classification yard, which is actually this area here. So in this particular yard, there's 50 different tracks in there. So we're separating each of those trains into, or each of the cars on all those trains into those tracks so that we can build new trains. So the first part is picking which track to hump, and then it comes down to an individual car basis of where should we put these in these 50 tracks such that I can most optimally be able to build the trains that I know need to go out. So obviously, each car has a class code which tells us where it's going to go next, and that tells us that corresponds to an outbound train, so we know what order and stuff. So obviously, they handle more class codes than they have tracks, so they only have 50 tracks, and it may handle 80 to 100. I don't remember what the actual number is anymore. It's more than 50.
Changes almost weekly.
So we can't have one track for one class. So we obviously have to figure out the best way to stack these up so I can put 2 things on one track and still be able to get everything out on time and in the correct order. So the next part is pulling. So once they're in the classification yard, and hopefully we've done that correctly, it should make this part easier. So basically with this, we go through and look at what trains we need to build, see where they are in the class yard, and try to connect up pulls. So to pull those cars out of the bowl and put them onto a new train. So we got that. And then departure driven, like I mentioned already, everything is driven off of what we know needs to go out. Outbound trains are the most important input. They tell us everything we need to know. I'll go into a little more of that in next slide or two. So some of the things that we've done as part of this product to help us build those planning algorithms or make the UI helpful for these yard masters that are ultimately going to be using this product. So class scoring, that's something that helps us a lot in that departure-driven planning. I'll go into that in the next slide. And then we have planning insights to kind of tell the user what we're doing, because it may not always be obvious, or it may seem like not the best decision until you see kind of how we were thinking about it. And then presenting our plan and the information that we're taking into account through a user interface. Oops, wrong way. All right, so class scoring. So like I talked about before, this is all based off of outbound trains. So I have this list of outbound trains, and this one leaves at 11, this one leaves at 12. I need to know that information, what classes it takes, so essentially where that train is going, and what order they need to be in. So this train may stop in three yards along the way. I need to know which one's first, second, third, so that we build the train in an order such that they can just chop off one block and leave it there as its final destination and move on. So basically, we take all that information and roll it up into a score to be used when we're looking at all the classification stuff, the humping and the pulling that we just talked about. So it basically tells us what things we can and can't put on top of each other. So if I know this train is like the 4th one out, I don't want to put something on the first train behind it, because then I'm not going to be able to pull those correctly. Yeah, so I think that's high level of that. The next part is planning insights. So like I mentioned before, this is an optimization algorithm. It may not always do what a human's going to do. It may be looking at things that you weren't and making different decisions than you would. So we built a thing to kind of help let the users know when we're doing something that might not be obvious and give them extra information as to what made us do that. So in this case, maybe, let's look at this first one here, new clean track. So I come across, there are specially marked cars in the yard, so there's like bad ordered cars that need to be repaired or clean cars that need to be cleaned. So we can't put those out on a train until that operation is done, so we have to collect those separately. So in this case, I came across one of those cars. I didn't have anywhere to put it, so I need to create a new track for that, and we're just letting them know about that. There's a lot of ones like that, and then there's things like train building rules or things with information that may not be accurate. So in this case, this one here that's expanded, the shiftable car thing here. So we're given information that tells us this car is a center beam car, so it could be loaded with logs or something that could shift as the train moves. And we don't want to put that next to other types of cars like tanker cars or something, because we don't want that to shove in and cause problems. So by default, all the information we're given is that this could be, so we separate those out. But in these cases, we don't know. It requires like a visual check for the yardmaster to look out the tower and see, oh no, that one's fine. You don't need to separate it based on the way it's loaded. So we have to present information like that and allow them to give input to us, so that we know that we don't have to do that, or we do. And then other train building ones similar to that, like not necessarily shiftable, but like flammable cars and things like that. We don't want to put them next to certain other things. So we're providing information when we do that, because it may not be obvious just looking at it. So these two cars may look the same, but we separated the two, but it's because I'm not allowed to put them next to each other, and you should go take a look at that. All right, and then to go along with that, just kind of the rest of the UI that presents the information that we're looking at and what we're expecting users to do. So on the left there, you've got so those are the trains that we know are currently coming towards my yard, when they're arriving, how many cars, where we're intending to put them right now. And then under that is the receiving yard. So these are where the trains that are already at the yard are parked. So they come in, they park on these tracks, get inspected, airbled, and then we pick from those to pick which one we want to hump. And so it provides other information here. So like the red knobs here, this track is blocked. I can't access it. So we know not that we can't use that. How much space is available, and then you can get details on it of what's actually there, what class codes, how long each of the cars are, and all that. And then on the right side, we have basically the plan views. So once we've come up with a plan based on all the information we've been given, we present it in a way that, so first we want you to hump receiving track 6. It's this many cars, it should take this long, and then there's ways to actually look at more details of that, of where each car is going to go. And then while you're doing that, these 2 trains are coming in, and we want you to park them on these 2 tracks. And then the next, do receiving track. And then from the pull side, similar kind of view, but you're going to pull these 14 cars out of class track 36 and put them on forwarding track 2 for this train 357. I think that's pretty much it. You want to?
Actually, do you want to talk a little bit more about like the planning and how quickly it plans and kind of the kind of overall algorithm type stuff?
Yeah. So we've got, this is a real-time planning system. So we're getting fed this information in real time as cars are moving, as they arrive at the yard. So information's always changing, like how much space is available on the track. Train times may change. So every time we get new information, we're planning. So every 2 minutes, this is constantly planning, coming up with a new plan, adjusting the plan. So if I had planned to put some cars into a class track in one plan, and then all of a sudden that track is blocked, or a car stalled on there and there's not enough space, we'll get that information quickly and replan again to plan around that. Yeah.
Cool.
That's
Yeah, so and we could talk, we just got like one or two more slides to kind of sum up, and then definitely some more questions for sure if you guys have them. One of the things that I just put this together last night. So, this type of system, I mean, it's really never been done to this level of detail, and so it's taken a few years. So we are very close to having it go live and stay in production in Macon, Georgia. That's the first location on Norfolk Southern, their hump yard there. And so as part of that, there's always this big change management curve that we have to go through. And so some of the things that Dave was mentioning about the planner making decisions that may not intuitively make sense, because as people, we can only consider so many variables, and they look at it and they're like, wait, that's a dumb decision, but in the broader context of things, it's actually it's going to be fine, but we can't see that far into the future. So the team actually this summer started putting together an emulator tool that allows us to project forward and run the simulation, or run the model. It's not quite a simulation, but it kind of is acting like one. And with some assumptions that we just always follow the plan. What would the yard look like? We take a current state, we load up a snapshot of how the yard looks right now, or at some point in the past. We keep track of all those. And then we could say, okay, if you just let the planner run, and it humped the cars in the sequence it wanted to, it's put them on the tracks based on the rules and decisions that it made. Trains departed, it built them according to how it's supposed to based on those rules. If you just let it do that and let it run for several days, how would things look? Because that's what the railroads that's what they're worried about. Like, if I let this thing run my yard, is it going to mess me up and then I get in trouble for it? That's what they're worried about. So we've actually done, they put that together, did a great job, and now we've got this tool we're incorporating into our testing, because we got to do a lot of this planning engine testing to make sure that all the rules that we put in a few years ago still make sense. Do we need to tweak them? Well, we just ran it. We got about 3 days into it, and then there's some weird cars that do some stuff that we have to take care of, because that's just how railroads work. But we got 3 days of good solid run, and I just looked at it last night, and so we took an inherited yard state. So what the yard masters had done, I think it was a couple weeks ago, and just for in case you've looked at NS's metrics at Macon, they're not running that well in the south right now. It's a lot of volume. Some issues. It's a very high dwell, very congested. They don't have power. There's those kind of typical issues that come up every once in a while. So it's a harder state to plan. Well, we took that state, and then we ran it, and 49 hours later, we actually had another 120 cars in the bowl, and we had fewer dirty tracks. Go back to my thesis, right? Clean, dirty, and pure tracks, and that we actually had fewer dirty tracks, more clean tracks, which are nicely stacked, so we were stacking more blocks in there. We actually had a couple more empty tracks, so we were getting more cars into the bowl, and they were being sorted better because the planning engine is doing what it's supposed to be doing. And so that's a really good indication. It's initial. We still got a lot more work to do as far as digging further into it. But initially, that's what that whole tool is all about. Can we better use those assets? The sooner you get the cars into the bowl and you get them in the right order, the better chance they have of making the outbound train they're supposed to be on. So ultimately, you run longer trains. If that's what you want to do, at least you're making connections, which is really what yards are all about. So that's really cool. Team's done a really great job with that. And just kind of the last slide, and again, that's actually the graphic that I had on those other ones, but you can kind of not see it here with the projector being what it's doing. But the vision that we have is we want to integrate across the solutions. Like I said, we want to break down the sort of traditional silos inside of how GE Transportation has done stuff, because the railroad, needs to do that as an industry. And so whether I'm looking at port and supply chain visibility, through my transportation management system, in fact, as we move into the flat yard space, which we're going to start later this year, we're not going to build a totally separate tool that's like its entire flat yard planner. We're just going to build modules that we're plugging into our existing transportation management system that the short lines use, because the user's already used to using that system, but now we're just going to provide the smarts behind it so things are sequenced, and here's the activities you need to do and when. So we're really starting to break down those barriers. We have a lot more coming on the edge devices. We're starting to develop an analytic that will actually track rail cars in the yard using video analytics. So we have a wireless mesh network that we're going to stand up over a Railyard, and then you're going to have basically camera. It's technology that actually exists in cities. We use it in San Diego, Atlanta, and actually Jacksonville. Actually have these devices. They were actually started out giving people parking tickets for parking violations, but then they got in trouble for that. So now we use it for identifying open parking spots, and that information gets fed to an app, and you can actually know where open parking spot is real time rather than having to drive around looking for one. And so it can actually identify gunshots, people in crosswalks, that kind of stuff. So we're going to use the same, at least base technology, and then we're applying it into rail yards to help with inventory management in flat yards so that we can track cars real time where they are in the yard. And so that's going to tie into all of this as we go forward. And so, again, the big vision is that we integrate across solutions, and there's interoperability. We're going to leverage the cloud technology that's out there and a lot of the the processing capabilities that are there. A lot more optimization. We're really just kind of on the forefront of that with our yard planner system, but there's a lot more that can be done. We were just talking with Tyler about multi-stage sorting and some of those techniques that have been out there from an academic perspective for a while. We're really hoping to actually get to do some of that and put it into practice in the future with the tools that we have. And then really leveraging common architecture, data foundations, and kind of the user experience that's going to be common across platforms. So definitely that's kind of a lot in that period of time. Looks like we still got a little bit of time for some questions. Definitely, for more information, we just actually put out a white paper this week. It's on our website, getransportation.com/whitepaper. You can get that. Or if you want to email me, I can send you a copy of it if you don't want to go to the website. So those are email addresses as well. There's more information on the website, GE Transportation. So, but yeah, if anybody has any questions, we'll do our best to answer them. And thanks for your time.
We do have time for a few questions. Farhan, I saw you had your hand up before.
Right. A couple of slides ago, you mentioned about how you tested this yard planner relative to how would the dispatcher make decision versus what kind of decisions would the tool make? And then you talked about what was the impact of the tool versus the actual sort of base case. Have you looked into like the network-wide type of impact and how was? So I guess where I'm leading to is you could make a really good impact in the yard level, but how would the rest of the network be compared to the base case? I guess what I'm asking.
Yeah. So the question was regarding sort of the results of our initial yard planner state test, and then have we looked at it from a more network perspective. So I guess just to make sure clear on that, we took the starting state of what the yard masters had done. Again, pretty good considering how much traffic they're dealing with. So it wasn't like it was a bad yard or anything. It was just high volume, so it's very hard to manage that. But then at that point, we sort of detached from reality, and then we just let the planner run. We didn't compare it, say, to what it would look like 2 days later in reality, because it's really hard to do that, because once you make a different decision, you start to diverge, and there's a whole I guess theory on that as what the best way to do it is. But really the point is, could we see, is planner following the rules, and if we allow it to do what it's doing, even though I might not understand one decision, overall my yard state is still going to be acceptable, or ideally, like it is, like we saw there, it's actually better because I'm getting more cars in the bowl and there's maintained cleanliness. So from a network perspective, we haven't actually really done a lot of, we're kind of getting this working first. But the idea is one of the first things that we want to do once yard planner is live at Macon is that there's several flat yards that Macon interacts with. And so like in today's world, Savannah, Georgia, there's a large port there. So Savannah, Georgia has a pretty good sized flat switching yard there that serves a lot of the customers in that area. And so out of Macon, they make one block, Savannah proper, and it's all Savannah cars. They all go to Savannah. Then the yard there switches them all out. Takes a shift, a shift and a half, 2 shifts to actually get them all switched out, so that they can then go run those trains to the customers. And so with a tool like Yard Planner in place, we can go ahead in today's world, like Dave was saying, maybe you're 70 blocks at Macon. The reason I don't have more blocks at Macon is it's too hard for a person to manage that. If you ask any superintendent of any yard in North America, they'd say, do you want more cars or do you want more blocks? Like, give me more cars and keep the number of blocks the same or less, right? That's what actually Tyler's whole dissertation is about. And so with a tool like this, that planning issue goes away, or at least it's reduced quite significantly, because now this can take all that into account, go ahead and make sure the activity is still getting done, so that train is still getting built with more complex blocking, and so that now you can actually take work out downstream. And so theoretically, we know what it's going to do. We just haven't actually run those models. We really don't have a way to model that, I think, right now. We may hear very shortly. We're actually building a service design tool that's going to, take into account train and blocking information to kind of help with that, because we have a lot of that data, from our systems. So that's, so we might be able to actually show that, but that's the theory, is like, hey, we can take work out upstream, and then, as you start to kind of connect yards, maybe not necessarily having the planning engines working in sync. We could go that route, but you may not even need to go to that level. So, yeah.
It's more of a on the general level. You talked about general toolkit that you provide, and a lot of that is geared towards streamlining operation and providing efficiencies. I'm curious on the international level. A lot of the companies are not private; they're state-run, and those companies generally have their inbuilt inefficiencies that they want to keep. They purposely hire more people than needed.
Right.
They purposely are run inefficiently. So as GE, I know that there are some good strides with Ukraine or Kazakhstan, but some of them would not be willing to go that route. So like, I'm curious, how does that conversation go with these type of government entities whenever,
Just change the objective function, maximize the number of employees.
No, it's actually, yeah, it's a good question. I mean, I know you're from Kazakhstan, and we've got a deal there. We're working actually over multi-year years. The roadmap has yard planners, one of those things down the road. But yeah, the value story is not the same, right? Here, it's labor is always a good thing you can pull. But I was down in Mexico City with a potential customer there. They're already a GE customer, but we're looking at doing yard planner there. And of course, yeah, they're viewed, right, as kind of a good thing for the community because they provide jobs. And so we can't go in and say, oh, you're going to cut yard master jobs if you put this in. That's not what's going to help. Now for them, it's more of a, well, hey, you've signed up to build this spur, this rail line to the new airport construction, because in Mexico City, I don't know if you've ever been there, but you can't get around. Like, traffic is nuts. It's crazy. So to get the materials, they're gonna use rail. Well, the yards are already very congested, and so we're going to be able to help with that. And here's where we think we can do that. And so it's the financial piece. Like, we had a call a few weeks ago. And I know the industry is starting to think about it, where the financial models that they use don't really support this kind of stuff, right? You can't really justify investing in these digital solutions with the way that we, normally it's labor and fuel. That's what gets you get the investment in the capital dollars. Well, that just doesn't work as much anymore because it's such a much broader perspective of things. And so we have to figure out how we kind of bust up those financial models and really say, well, what's the value of, having fewer cars online, which has sort of been done. We see the value of that by various operating philosophies that have been in place the last few years. I think we've got some statistics right now. About 20% of all North American rail cars are in storage right now. I can't remember, or maybe it's 20. I forget it's a good chunk of stuff, right? I mean, and locomotives right now as well, because hey, we're turning the assets faster. That's great, but nobody really said that's. From a financial perspective, they had the number. They just, certain people just said, do it because that's the right thing to do, and they did it. And so yeah, depending on the international space, we'll have to look at it, kind of very specific. But a lot of the international, company, like Ukraine now, we just signed that $1 billion deal with them just a couple weeks ago. India as well. A lot of it's about modernization, to kind of position themselves strategically to be that preferred, whether it's, that pipeline as goods are moving across various countries, like Kazakhstan, or India. It's just they need to, they can't keep moving the amount of people and stuff they need to move without making it more efficient. And it's not really about jobs. It's just about improving, the use of the assets.
We've got a couple of online questions.
Okay.
First is, how is the yard planner algorithm optimized, i.e. what outputs are you using for feedback?
Sure.
Yeah, so a lot of things we're looking at is to minimize like dwell time in the yard. So we want the cars to be there less. So the more efficient we get them through the yard, the better. And then there's also yard cleanliness, like I think Jeremiah talked about before. We don't want to have a lot of re-hump tracks or tracks that they have to handle again to get the cars in the right order. And then there's making sure the trains are built correctly and on time. And that's a lot of the things that we're looking at trying to help improve.
Okay, we have another online question, also related to Yard Planner. And actually it applies to either Yard Planner or other tactical planning tools. Has machine learning been built in to improve the performance over time? And if not, how does the tool deal with slowly changing conditions?
He's the expert, so.
So no, there's not machine learning right now. And it's something that we're looking at, but because of the way these work, there's an infinite possibility of things we can look at. So that's why that will become important. Right now, we're focusing on the general set of stuff that we know about, and then expanding from there.
Urbana. Well, I guess my last one is Amazon going to buy GE Transportation?
Well, at this point, yeah, we don't know much more than probably you guys know. So we're just business as usual. But I think overall we're excited about the opportunity for, being a kind of our own entity or some other form. But maybe it makes sense. I don't know.
All right, well, thank you very much.